Yeah. Okay. His name is Max Koretskyi, but we call him NG Wizard.
We needed in-depth knowledge, and this guy delivered.
If faster performance is what you and your team need, check out the secret behind Angular's lightning speed.
Okay. Right. Hey, hi everyone. Yes, my name is Max. I used to be NG Wizard now, and then I was Wizard, and then I became confident enough to use my real name. So now I'm known just Max Koretskyi. Yeah, so I work at AgiGrid. This is where, how many people know AgiGrid? Well, that's a lot. Yeah, that's a lot. Yeah. Yeah, we're doing data grid, JavaScript data grid. As far as I can tell, we're doing a pretty great job. So if you need data grid, give it a try. And also Angular in depth. Anyone knows Angular in depth? Okay, also. It's funny, less people than who work with AgiGrid. I'm going to tell Niall that. Yeah, and today we're going to talk about secrets behind Angular's lightning speed. So, how many Angular developers here? Okay. And JavaScript developers? Do we have JavaScript developers too? Not sure, right? Yeah. Anyone worked with other frameworks? React, maybe Vue? Okay. Good. Well, this talk, although it's about Angular, right? It has Angular in its title. The knowledge I'm going to talk about today, the information, will be useful for any JavaScript developer, anyone who works in the web with any framework, because I will be talking more about general concepts and the fact that Angular uses them, well, proves them that they're useful, but other frameworks use the stuff that I'll be talking about today as well. Now, usually the second slide is about me, you know, my writing activities, speaking activities, and you know, kind of there's a lot of criticism in this world, and I really like to use it to fuel my you know, energy. So where do I go to find criticism? I go to YouTube. And you know, I watched comments under my talks. So one of my talks, I went there, and there was this great comment by somebody who said, it's funny that this guy has never written a line of code in his life, yet he teaches us and explains how stuff works, how to write code, and so on. And you know, I first got a little bit depressed. I spent a lot of time trying to figure this stuff out and explain it, but then I realized, what makes him think that I never written a line of code? And then I realized, because when I go on stage, I only talk about how I write articles, how I speak at conferences, you know, how I do research, but I never talk that I actually write code. So now I corrected this mistake, and here I've been writing code for 6 months, or actually 6 years, yeah. Right, yeah. And yeah, I do know a little bit of coding. And besides that, yeah, a lot of extra stuff. Okay. So now, what makes Angular fast? In fact, what makes any framework fast? Well, you can break it down into 3 components. At least that's how I did it. So you need to write optimized code. You need to use proper data structures. There is a specific class of data structures that are used as an optimization layer. They go hand in hand with regular data structures, like arrays, JavaScript, hash maps. And together, they make the system very performant. And Angular actually uses one kind of such data structures known as BloomFilters, and we'll become familiar today with it. And also, it helps if you have a compiler. And does Angular have a compiler? Yes, I think this is one of the things that makes Angular maybe more complicated than other frameworks, because sometimes you need to figure out the errors with the compiler and what it's actually doing. So let's start with optimized code. Okay. So actually, you can find a lot of techniques that Angular team uses in the document called perf.nodes, in their GitHub repository. And well, they don't use recursive functions. I did this joke. I said, because it's very complicated, you know, recursive functions very complicated, and so Angular team doesn't use them. But I'm not sure that's appropriate. So they don't use it because actually they cannot be inlined by virtual machine. That's kind of optimization technique that V8 uses. They sometimes use regular for loops. Do you guys use for loops? Okay. What do you use instead of for loops? For each? Yeah, so like for each is more a declarative way, right? It lets you lets others understand what exactly you're trying to do. But sometimes for each or any other method on array is slower, so Angular team runs a lot of performance tests to figure out which one to use. They do use linked lists. Anyone knows anything about linked lists? Okay, great, yeah. No top-level variables, bit fills, a lot of stuff. But the most important thing, they use, or they try to ensure monomorphic property access. And this stuff is actually very complicated. It took me, I think, 3 months before I could figure out what it is. And I use a lot of help. Benedict from Google V8 team, he helped me understand it. I watched a lot of talks. I read a lot of articles. This stuff is complicated. Probably you will never use it in your own code. But it also helps you understand how virtual machines work, how they optimize stuff. So, and it is important to know what it is, and actually for framework writers to use it, because monomorphic property access can be up to 100 times faster than megamorphic. So when I'm talking about property access, right? Imagine there's a function with a few property accesses inside, and you have a bunch of functions like that, say change detection cycle. And all those functions are executed several times per second when change detection runs. So in each of those property accesses is 100 times faster, right? So you can imagine the impact it can have if they don't use correct property access, right? So you feel the need to use it already? Yeah? Someone? Okay, so this is kind of a function that's used during change detection, okay? So here you have .o.x is a property access. You use it every day. So can we say if this is a monomorphic property access or megamorphic? By just looking at the function. It's actually interesting that we cannot. And the way the type of this property access is determined during runtime, when this function is executed and virtual machine analyzes the information or that you pass down to this function, the arguments, the type of arguments, specifically objects, and then it determines what kind of property access that is. We will see now how it does it. I tried to condense all this knowledge that I learned in 3 months into one slide. So there's little chance you'll understand it, but like I did my best job anyway. After the talk, I will be available to answer questions, follow-up questions. But the question is, why do they need this? What is so difficult about accessing a property, right? When we look at this, it's not difficult. So virtual machines should do it pretty quickly. But in fact, this is very, very complicated process because JavaScript is an interpreted language. So it's defined in runtime where exactly the value for this property is located in memory, right? As opposed to, say, static languages that compile directly into memory addresses. So here it's very complicated. It can be anywhere. And the process involves a lot of steps. Now, when you have to do something over and over again to get a value, what is the common technique that we use to, optimize that? Cache, exactly. We resolve that value and we cache it. And we put something to compare against, right, to figure out if we need to invalidate cache, right? That's exactly what they do. They use the technique called inline caching. So the virtual machine tries to figure out where to find that value in memory, goes through very complicated process, and once it gets this value, it needs to put it in cache. Okay, so here how it works. So suppose you have this function. Internally, virtual machine represents your function as the closure object. So it's under the hood. It's, I don't know, C++ object. And there is a feedback vector, which another word for cache. So with each closure, there is an attached cache. And virtual machines, as your function is being executed, will put some information there. So suppose now you call that function, you pass in an object. It goes through complicated process with a lot of steps to figure out the shape. I don't have time to talk about shapes, but basically it's just the metadata. It's the object that describes your JavaScript object, which properties it has, like this define something. I actually forgot the name for the property on the method. Do you guys remember that? Where you can declare getters, setters. Yeah, define property metadata, exactly. So this is where it puts all this information on this shape object. But most importantly, it describes the layout of the object, which properties it has, and the order of these properties. And based on that, based on the order of these properties, it also describes the offset, which means where in memory the value is located with regards to the pointer to the function. OK, so this is not important, actually. What is this shape? What's important is that each object has this shape, right? Each object has different layouts of properties. So once it resolved the shape, resolved the metadata, resolved the offset, it now knows exactly the address that where it can find the property next time, the value. OK, so it needs to cache it, so it puts it here, offset. But remember I told you, right, we need something to compare against. So this is shape is what we also put in the cache. OK, so next time when the virtual machine needs to resolve a value for a particular object, what it needs to do is just compare the shape, right? If the shape matches, it means that this object has the same number of properties in the same order. It means that the offset is also same. So I'll just use the value from the cache. No need to go through this resolution process again. Now, here's where the monomorphic property term comes in play. Each cache has, what does cache have? Like what characteristics a cache has? It's fast. Yeah, I mean, yeah, correct. Array, right? Like an array. It has, but it also has size. I mean, my question wasn't clear, that clearly formulated. Anyway, it's always difficult. Yes, it has size. And it has capacity, basically, right? How many items you could put inside, and how many items are currently in there. So here, feedback vector also, or inline cache, also has size and capacity. And it's interesting that depending on how many items are there, it defines the state of this cache. So what is the word for one? Latin word. Does anyone know Latin here? No? It's maybe it's not Latin. Mono, right? I'm not sure if it's Latin, but it's mono, right? Just one. So if there is only one item in the cache, only one shape, the state is defined as mono. Okay. And so here, right here, you can see mono word appears. Right? So it means mono. And this is how you break down the monomorphic property access. Basically, it means that inside this function, there is a property access on an object. This function has been called with object, or with many objects, and all those objects share the same shape. Right? It means that in the cache, there is only one shape that we have to validate against. Okay? And it's very fast, right? It's just one comparison. You can do it very quickly. So you do one comparison, and you decide either take the value from the cache or go through the lengthy process with a lot of steps to resolve the value for another property, okay? Now, so this is the basic idea behind inline cache. But you can put a lot more values in the cache, right? You may call a function with different sets of objects. So some objects will have X properties, some X and Y. Some objects will have prototypes, different prototypes. So here, for example, I call this function with, these are different objects, right? Because we create them in line, but they all have the same shape, same number of properties in the same order. So even though we have called function 3 times here, inside the cache of getX function, there is still only one shape in the cache. So all property access here will be monomorphic. But now you may call this function and pass an object that has different layout, right? Now we've added property Z, or we pass in an object with a different prototype. So now for each of those calls, virtual machine starts to put more values into the inline cache, right? For the second object, for the object with the Z property, for the object with different prototypes. And so the number of items in the cache grows. And as soon as it's more than 2, the state is defined as polymorphic, like poly word for many. And it's still OK, right? If you have, what you need to introduce is basically if statements, right? If it equals this shape, then resolve the value from this cache. If it equals shape B, resolve from, so it's still OK, but how many if statements can you have, right? You cannot have 1 million if statements, right? It wouldn't be correct. Maybe then actually resolving the value using the basic algorithm would be faster than do all those comparisons, okay? And so they, or the V8 writers, they defined the maximum capacity of this inline cache as 4 items. So if you call the function and pass in objects of different shapes, and there's just 4 different shapes, then it still works pretty fast. It's slower than monomorphic, where there's only 1 item in an array. But it's still pretty fast. But once you get over 5 or 4 different shapes, right, then what happens is that internal inline cache on this particular function is no longer functioning, right? It's no longer used. They use the global cache, they put in value there, and the process is a lot slower. So if you actually need numbers, go and watch talk of Mishko on Angular Connect, where he actually showed the programs, the software they used to run these tests, and they actually show you the difference in time if the property is monomorphic or megamorphic. Okay, so they do a lot of these comparisons. So what do they do to ensure that all property access are monomorphic? Basically, we have a lot of view nodes here, different types of nodes in Angular template, elements, text, component, something else. What they need to do, they need to ensure that there is only one data structure of one shape or one layout that describes all those data structures. And once we have it, we need a property type to distinguish between different types of nodes. So basically, if you check out Angular sources, you will see that many functions have switch statement that distinguishes, then gets a node of the same shape, so all shapes, and this view node, right? So when you have Angular template, every node in the template is converted into or represented eternally as a T node or view node, depending on what compiler you're using. But inside, so this is how Angular team ensures that all property access And this is important, for example, if you have a function that is called once per lifetime of an application, there is no point trying to ensure that property access is monomorphic there, right? However, if you have functions that run several times per second, like change detection that runs a lot of times, you need to ensure that these particular functions execute as fast as possible. And this is where it makes sense to focus attention. OK, so this has been monomorphic property access. So tell me if it's clear at least 10%, then my job is done. Like 10%. OK, nice, nice. Now we move to probabilistic data structures. So I've already told you that this is a special kind of data structures that do not replace regular data structures like arrays and hash maps that we get used to using in JavaScript, but they go hand in hand. And one of them is BloomFilter. So what is BloomFilter? Now imagine you have an array, and you have 1 million items in this array. So you need to figure out if there is item in the list on this array or not. What are you going to do? You will need to run comparison, linear comparison, one by one through every single item. And although the comparison might be fast, like, for example, reference check, right? You don't do deep checks. But even though it's fast, when you have 1 million items, it's still a lot longer. So what if I told you there is a method to check if there is item in an array or not with just one operation, regardless of how many items you have in an array? And this is where Bloom filters come in play. So it allows you to answer simple question, OK? If the item is in the set or not, okay? And it's widely used. So here it's used in databases. Every database is using some kind of Bloom filter. It's in what is it? What is this? Networking. Yes, exactly. So it's used in networking, and it's also used in one thing that everyone thinks will make them rich today. What is it? Huh? Bitcoin, right? Cryptocurrency. Yeah. So it's even used there. Blockchain, yeah, all this stuff. So as I already told you, it answers this question. But it's tricky, you know. It's fast, but we always have trade-offs. For example, Angular is fast, React is slower. But React is more flexible, and Angular is less flexible, more rigid. Anyone who has ever worked with component factories and dynamic components knows that there's a lot you have to know to be able to load dynamically components. So here as well, you have a trade-off. And the trade-off is that you never get the answer yes. It's never sure. Yeah. The probability varies. However, you always get the answer no that is correct. So you can trust the answer no. Now, when do you think it makes sense to use this kind of data structure? Again, when it's no, it's always correct. When it's yes, we don't know. So when do you think you need to use this kind of data structure? When most of the answers you expect to be no. Like, OK. And there is a case in Angular where they think that no is the most common answer. But first, I want to show you a little bit how this data structure works. So probabilistic data structure, OK? They all share same characteristics. First, they all use hashing functions. OK, what does hashing function return? Huh? A number, correct. Most people think it returns a string because there is 5 and there is letters there. But under the hood, it's numbers. Probabilistic data structures, they never store items. So that's why they cannot be used instead of regular data structures. They only partially store them. And I'll show you now how it works. So suppose you have John, Anna, and Tom. And now you could put them in an array, right, and go through each item to compare them. But instead, we want to use BloomFilter. So BloomFilter is a bit filled. Well, actually, it can be anything. But here I'm using a bit filled to demonstrate the concept. So it's a lot of zeros and ones. Now, we need a Cashin function. So we know the hashing function does some magic and return a number. They're very complicated hashing functions. Here it's a little bit less complicated than most common functions. I just take the first value and yeah, and doing something there as well. So this I found it on StackOverflow actually. They never explain what it does, but right. Okay. If anyone's not sure what it's doing, just come after the talk. I'll explain you. So now we calculate the number. It's 2. And what we need to do is just basically change from 0 to 1. We say that the number, that the second place is now occupied. So we mark it with the number 1, okay? And here, because it's a bit filled, I'm using bitwise operators to set the build. But if it was an array, you would just, did second place, put 1 there. And now when we need to compare it, or figure out if John is in the set or not, we run John through the same mechanism. We get the same number because all hashing functions should be guaranteed to produce the same result for the same input parameter. And you just do that. And it gives you number 2, so you just check if there is anything on the number 2, right? So I told you that if you get the number no, or the answer no, it's always correct. And it is true because if there is nothing there, right? But why is it not always yes? Or yes is always correct?
Hash collisions.
Exactly, because you can have hash collisions. It means that when 2 very different values go into the same function, the returning result is the same for both. And here, for example, since I'm using first letter, right? Instead of John, I could have Jane, and it would give me number 2 too. So now I don't know if Jane or John is there, but if it's 0, I know that neither John nor Jane is in the array, okay? So, okay, now I told you that there is a case in Angular where most of the answers is no. And this is hierarchical injector system. Now, in Angular, it creates injectors for every single component. You know that, right? So suppose the bottommost component needs to resolve a widget manager, okay? And it doesn't know which injector defines this widget manager. So what does it have to do? It has to go through every single injector and do the check. And most of the injectors won't have it. In fact, I think like all injectors but one won't have the widget, right? I'm not sure how you write in your applications, but this is this is how I do it. Yeah, so it's a lot of checks. And if you have very large hierarchy of components with a lot of services, it's going to take a while. And here, most of the answers is no, which is exactly the case for our BloomFilters. So we just attach BloomFilters to every single injector. When we initiate the application, we pre-fill or fill the BloomFilters, right? We encode every single item in the injector into the BloomFilter. And it's going to take some time when the application bootstraps, but when in runtime it needs to resolve a service, it works pretty fast, right? So it's just one operation. No, we trust it, we go up. No, we trust it, we go up, and that's the process. Very, very fast. Yeah. So this wide dependency injection system works pretty great here. Okay. And if we find it, we resolve it. So I have 2 minutes left. So here should be about 40% of the standard, from 40 to 60, I think. How many? 40, 60? Oh, it's even less. Wondering why. 15, maybe? Yeah. Okay. Okay. But this stuff is complicated. I should say that. Don't feel bad if you don't understand it. I mean, it took me a while to figure out, and then a while more, and then a few questions to other people, and then it clicked, you know? So, Angular compiler, 1 minute. I might go over a little bit, but why does Angular have a compiler? I asked this question on Twitter, and they told me that it would be great to insert some great joke here, but I didn't have it. So they told me to translate this into something that browsers understand. Browsers don't understand these things. Again, Stack Overflow. Right? You already know that. So here's how the output looks like from the new Ivy compiler. Okay. But it's interesting that in React, they have JSX compiler that does, I can take extra 5 minutes. I will take them. So, React has JSX compiler. So, and because I like React, I like Angular, I wanted to understand what is the difference, right? What is the difference between these compilers? And here's how they declare templates in React. And this is the output of the compiler, JSX compiler. Now here you can see both in comparison. What you can notice here is that React's compiler simply defines a view using JavaScript object. So there is no logic there. It's simply definition of a view, right? What elements, what their properties are, and so on, and children. In contrast to that, Angular's compiler produces runtime code. It produces, so all this stuff, text binding, interpolation, how they call it? Anyone knows? Yeah, they call it instructions. The IV set instructions. So these basically are just function names that should be supplied with the framework in runtime. So the compiler basically just calls functions, produces function calls, and that's the job of the compiler. And the runtime supplies the body of these functions, right? Somebody has to write the body. So that's the idea here. And so you can see it's very, very different to React, to JSX compiler, right? Here, the compiler is doing a lot of work, a lot of analysis to figure out which functions need to be called. And this is the code that is executed during change detection, right? So it should be optimized, and it should only call the functions that are really needed. And because of that, here's, for example, you have a DOM structure. In React, they need to go through every single node and do the check-in, right? If the UL unordered list properties have changed, if the children have changed, and then go down to every single child and do this comparison. So a lot of work. Whereas in Angular, because the compiler has already analyzed that, it knows that, for example, it just needs to check only one single node, right? Because the compiler has done the work. So here, it will produce only one function call. And all we need in runtime is just one function body. OK? It's very, very different to React. So is Angular a lot better than React? Because it does it. What is the answer? It is. Yeah, for some, it is, yes. But actually, again, this is a trade-off. Angular is rigid. So you define a template only once, and then you have no control over this template. And in order to introduce dynamic stuff to the template, what do we have? What is the structure in templates that you use every day to introduce something that changes in the template? Expressions, right, and more bindings, yeah, directives. Yeah, basically, yeah, all those answers are correct. The directives was the answer I was looking for. Exactly, we have directives. But in React, they can return whatever they want during every single change detection cycle from the, say, render function. So the component can define different views every single time. They don't need directives because they're extremely flexible. But this flexibility comes with a cost, right? Because it returns whatever it can, whatever it wants. You need to check every single time, every single node. That's the trade-off. And besides direct render instructions, one thing that compiler enables is smaller runtime. I just told you that compiler produces instructions or function calls, right? So basically, the compilation output is just a lot of function calls. So because it analyzes your template beforehand, it knows that, for example, you never use ng style directive. So there is no need to bundle together code or body for ng style function, right? It will never be used in runtime. So here, for example, because you have only one expression, there is a need to include only code for text binding in the bundle and load it to the web. Okay? Once you add ng style, the compiler produces property function call or the instruction. So you need to include property code or this functions code into bundle. And so you can see that the more stuff you include in your template, the more they need to bundle together into a final output. But here it's flexible. For example, in React, they have no idea what you will need in runtime. So they always supply entire runtime. Here in Angular, with this Ivy compiler, you will have smaller runtimes. That's basically another thing enabled by compilers. OK, that's it. So here it's the picture of the mountain. It has nothing to do with Angular, but it has something to do with you being a better developer, growing every day. So it's a metaphor, or metaphora. Well, yeah. So basically here, why I'm giving these talks, my hope is that even though you may understand only 10% of this, it still might get you interested in this kind of stuff or any other kind of stuff that you don't normally use at work, right? And then maybe you'll, in some evening, go and explore and see what is there as well besides just Angular or React or besides front end, what is backend, what is Cashin, and all this stuff. And I think this is how, by becoming interested and by exploring, we all become better engineers. So this is the idea, and I hope that my talk has inspired you to do this. OK, thank you.